Brad Williams, Frugal Finance, the basis point model. The basis point model focuses on the price effect of 1 basis point change in yields. For example, we have seen that a change in 1 basis point causes a $25 change in the future price of a T-bill or euro-dollar contract. Assume that today is April 2nd and that a firm plans to issue 50 million of 180-day commercial paper in 6 weeks. For 1 basis point yield change, the price of a 180-day commercial will change twice as much as the 90-day T-bill futures contract, assuming equal face value amounts. In other words, on 1 million of 180-day commercial paper, a 1 basis point yield change causes a $50 price change. In an important sense, the commercial paper will be twice as sensitive to a change in yields. To reflect this greater sensitivity, we can use the BP model to compute the following hedge ratio. Hedge ratio, BPC of S divided by BPC of F, where BPC of S is the dollar price change for 1 basis point change in the spot instrument, and BPCF is the dollar price change for 1 basis point change in the futures instrument. The ratio BPCS divided by CF indicate the relative number of contracts to trade. In our commercial paper example, the cash basis change is twice as great as the future price change, so the hedge ratio is -2.0. To explore the effect of this weighting, consider the following BP model hedge of the commercial paper. Planning to issue commercial paper, the firm will lose if rates rise because the firm will receive less cash for its commercial paper. As it needs to sell the commercial paper, it is now long commercial paper, and the firm must hedge by selling futures. With a -2 hedge ratio and a 50 million face value commitment in the cash market, the firm should sell 100 T-bill futures contracts. Table 618 presents the BP model transaction. After rates on both sides of the contract move by 4 to 5 basis points, we have the following results. In the cash market, the firm receives 112,000 less than anticipated for its commercial paper. This loss, however, is exactly offset by the price movements on the 100 million of T-bills underlying the futures position. The BP model helped identify the correct number of futures to trade for each unit in the cash market. By contrast, the FVN model would have suggested trading only 50 futures, which would have hedged only half of the loss. Here is an example, pretty much what I just stated. April 2nd, firm anticipates issuing 50 million in 180-day commercial paper in 45 days at a yield of 11%. Firm sells 100 million T-bill June future contracts yielding 10% with an index value of 90. May 15th, spot market and future markets have both risen 45 basis points. The spot rate is now 11.45 and the futures market yield is 10.45. Cash market effect. Each basis point move causes a price change of 50 per $1 million face value. Firm will receive 112,000 less for commercial paper due to the change in rates. 45 basis points, 50 times 50 equals -112. Future market effect, each basis point increase give a future market profit of $25 per contract. Future profit equals 45 basis points times 25 times 100 contracts equals 125,000. Sometimes the yields may not change by the same amount as they did in Table 618. In that case, the hedger may wish to incorporate the relative volatility of the yields into the hedge ratio. For example, assume that the commercial paper rate is 25% more volatile than the T-bill futures rate. In other words, a 100 basis point rise in the T-bill futures rate normally might be accompanied by a 125 basis point rise in the commercial paper rate. To give the same total price change in the futures market as in the cash position, we would need to consider the difference in volatility in determining the hedge ratio. In that case, the hedge ratio becomes HR equals BPCS divided by BPC of F times RV, where RV is the volatility of the cash market yield relative to the futures yield, normally found by regressing the yield of the cash market instrument in the futures market yield. If we incorporate RV, assumed to be 1.25, to our commercial paper hedge, the transaction will appear as follows as shown below in Table 619. If we incorporate RV, assumed to be 1.25 into our commercial paper hedge, the transaction would appear as shown below in Table 619. Now the hedge ratio is as follows. 50 divided by 25 times 1.25 is equal to negative 2.5. We're going to increase the number of contracts. So here, hedge ratio, firm anticipates 50 million, 180-day commercial paper, 45 days yield. Firm sells 125 T-bill June futures, contracts yielding 10% with an index value of 90. Spot price and futures markets have both risen 56 basis points. The spot rate is now 11.45 and the futures rates have risen to 10.45. Sit there and map this out and work through the logic. Cash market, future market, each basis point move causes a price change of 50 per million. Firm will receive 112 less for commercial paper due to the change in rates, 56 basis points times 50 times 50, 140 grand. Each basis point increase give a futures market profit of 25 per contract, futures profit 45 times 25 times 125, 140. Net wealth change, $625. Consequently, the hedger sells. Why is the hedger selling 125 T-bill future contracts? Assume again that the T-bill yield rises by 45 basis points. Also, and work that out. Why? Why is that happening? What's going on here? Map this out in simple terms. Also, true to its greater relative volatility, the commercial paper yield moves 56 basis points, 125 times as much. Because more T-bill futures were sold, the T-bill futures profit still almost exactly offsets the commercial paper. Brad Williams, Frugal Finance. Keep working at it.